Hello everyone. This video is going to be about isotopes and average atomic mass. So probably to start out we need to know what an isotope is. So isotopes are the atoms of the same elements with different numbers of neutrons, which gives them different mass numbers, because mass number is equal to the number of protons plus the number of neutrons. And so it's basically as simple as that. So in nature, elements don't all have the same weight. You find different numbers of carbon has different isotopes. Chlorine, a lot of elements have different isotopes because they have different number of neutrons. So for example, there's carbon 12 and carbon 14. And so basically to find the mass number of these, so it's your proton number, and all carbons have 6 protons. So when you're doing this, you have to remember the element's always going to have the same amount of protons, the same atomic number, because that's what makes it that element. And then you have to add the number of neutrons to get it to equal, for this one 12 and this one 14. And so this, you need 6 neutrons and you need 8. So these aren't charged, these are just neutral carbons, and that's how you get the mass number for isotopes. So this is really the main thing, the best way to kind of remember how to get the mass number. Okay, so what kind of goes hand in hand with mass number is average atomic mass. So what average atomic mass is, it is the weighted average of all known isotopes for an element. So that is that decimal number you see on the periodic table, which is rounded to known sig figs. They're measured in atomic mass units, which are either abbreviated as AMU or U. And so a weighted average is basically when not all parts of what you're averaging are the same. So a lot of times in math, we do averages and you just add all the numbers up and divide how many there are. Well, when we do average atomic mass, we're not going to divide by the amount we added, because it's weighted and we'll take the weight into consideration. So there's basically 3 steps when you do this. So step 1, there goes my computer. Okay, oops, that's T. That's funny. Okay. Step 1, because I can write, convert the percentage you were given into decimals. So step 2 is to multiply your percentages, which are now decimals, by the mass. And then step 3 is to add and round to sig figs. So I'll just do one quick example. So in nature, there's my pen. Okay, there's chlorine 35 and chlorine 37. So chlorine 37's mass number is 34.9689 AMU, and chlorine 37s is 36.9659. And in nature, chlorine 35, it occurs about 75.771% of the time, while chlorine 37 only occurs 24.229% of the time. So, now we just use the steps. So the first thing is to convert our percentages into decimals. And so that's pretty easy. You just move the decimal place 2 places to the left. So that gives us 0.75771 and 0.24229. Next is to multiply those percentages that are now decimals by their corresponding mass. So 34.9689 times 0.75771. And then again with the other one. Okay, now we need to get those numbers. So this equals 26.496 AMU, and this equals 8.9565 AMU. So now we're just going to add those numbers. Which gives us a grand total of 35.4525 AMU. But we have to round to known sig figs. So if we go back to the original problem, because there's multiplying and dividing and adding, you just go with the multiplication and division rules for sig figs and just least amount of sig figs. So as we see here, these percentages both only have 5. So our answer is to have 5 sig figs, and right now it has 6. So 35.453 AMU is the grand total. So that's basically it for isotopes and average atomic mass. It's pretty simple. If you have any questions, you can just ask me. So thanks so much for watching. Bye.